This lesson looks at applying properties of quadratic functions. So we have seen that the vertex form is extremely useful for telling us about what a quadratic form looks like. It tells us the vertex, the shape, how it opens. So this can all be extremely useful in light of optimization problems where we're looking for a maximum of something or a minimum of something. The vertex tells us about the extreme values. But first, before we get to some of these optimization problems, we need to gather up some tools that'll make it easier for us to work with the equations. So let's work towards it. What do we know about this graph? Well, it's not in vertex form, so it's kind of difficult to figure out what the vertex is, what the shape is, and all these other things. So it is nice to try to get it into vertex form, but how do we get it into vertex form? Well, that can be done by completing the square. So let's just review that process and see how it works. So remember, completing the square is taking a look at the x squared and x part so that we can add something and subtract something so that we can have that squared bit with these other parts on it. So we're using the perfect square trinomial formula. Now remember, we don't want a leading coefficient, so let's factor it out of the first two terms. So you've got x squared plus 4x, and then I'm going to leave some room here for addition of an extra term, plus 5. So we can only add or subtract, add a term if we're going to subtract it away. And what term do we need to add in order for this to be a perfect square trinomial? Well, that's always done by taking half the middle term and squaring it. So half of 4 is 2, and then squared is going to be 4. So we're going to add 4, but we also need to subtract 4 at the same time in order to compensate. Now we don't really care about this negative 4, so we're going to multiply it out by the 2 and kick it out of the bracket. So we have 2 times x squared plus 4x plus 4, which is our desired perfect square format, but this negative 4 also needs to not be forgotten. Subtract 8, because that's 2 times the negative 4 plus 5. So now we can convert this to our perfect square trinomial of x plus 2 squared, and then you have negative 8 plus 5, which is negative 3. Great, so this is a little more informative. It tells us the vertex is negative 2, negative 3. It tells us the shape. It's all multiplied by 2, so it's a narrow parabola. It tells us about the opening, that it's opening up, not down. And it tells us, because it's opening up, that it has a minimum. And that'll be useful in our optimization. Now, the other things that are being asked for here are the discriminant and the x-intercepts. So if we just sketch this out, it probably looks like something like negative 2, negative 3, opening up, quite narrow, possibly like this, possibly. But there's one more thing that we don't really know, is where does it cross the x-axis? Meaning, when does this answer equal 0? So if this answer is desired to be 0, those 2 points were the 2 solutions that the quadratic formula told us about. So if you recall the quadratic formula, that would have been negative b plus minus b squared minus 4ac over 2a. If we look at that, that'll actually tell us those 2 points. That'll tell us the x-intercepts. So let's try that out. Negative 8 plus minus 64 minus 8 times 5 So that'll be 24 and then over 4. 24 can simplify to negative 8 plus or minus 2 root 6 over 4. And that can also simplify by factoring out a 2. So that'll be negative 8 plus or minus, negative 4 plus or minus root 6 over 2. So our 2 points there are negative 4 plus root 6 over 2 and negative 4 minus root 6 over 2. You could approximate those as negative 0.78 and negative 3.22. Right, those 2 points are right there. That's where the x-axis is being crossed. Now let's just take a look at the discriminant. The discriminant is 24. And what does that tell us? What do you think the discriminant tells us? Right, so we've got our x-intercepts here. One at negative 3.22, one at negative 0.78. But the discriminant told us that there were 2 answers. So if the discriminant, say, was 0, then you would only have 1 answer. If the discriminant was negative, you would have no answer, so it wouldn't be crossing. We'll review that in a little bit, but these are some of the things that are important to look at when you have an equation, and sometimes they're useful in solving a problem. So let's just generalize the vertex form conversion. So let's take completing the square approach and apply it to this general standard form quadratic. So remember, we first want to focus in on the 2 first terms. We don't want this leading coefficient, so we factor it out. We want to leave some room because we want to add and subtract something, which will be half of this, b over 2a, but squared. So that'll be b squared over 4a squared. But if we add it, we also need to subtract it. Now we don't actually want this guy, so we want to multiply it by a to kick it out. So we've got a, and then x squared plus b over a plus b squared over 4a squared, and then minus the a times the b squared over the 4a squared plus c. So this a will simplify, and the c, if we want to simplify it, we're going to need to make it a common denominator, so it'll be 4ac over 4a. And then when we put that together, we get negative b squared plus 4ac over 4a. And here we have a x plus b over 2a squared. So remember that the whole point of this is so that we can generalize how to find a vertex. And remember, the vertex comes from these 2 parts, the negative of this and the positive of this. This is our hk. So what this tells us is that our vertex has x value of negative b over 2a. Now this is going to be extremely useful to shortcut our process of completing the square in the future. It's also interesting to note that this is pretty much almost the same as the other part of the formula for quadratics, right? If you factor out the negative, this will be b squared minus 4ac. So let's summarize that. The coordinates of the vertex, based on the standard form, will always be like this. Now, these are some equivalent ways of rewriting it. Essentially, This triangle is implying the discriminant. Remember, that's called the discriminant. However, this other part is quite complicated. So we should actually just focus on the x part, because if you know the x part, you can just plug it in once you know it as a number and find the y value. We also know that once we have the x value of the vertex, we have the axis of symmetry, which is right here, going straight through the vertex. Now, I've highlighted this negative b over 2a because that's what's really important here, right? That tells us what this x value is, and really, just like I mentioned, you can always plug it in and find it. Another thing to notice is that the negative b over 2a is essentially that one part. It's as if the discriminant is 0, right? If you shifted it up, it'd be here. The discriminant would be 0, would give us this type of parabola. So the negative b over 2a is an important thing to know. The discriminant is also extremely useful for us. So it's a little bit previously, I noted that knowing what the discriminant is helped us determine what kind of crossing points we have, what kind of solutions we have, what kind of x-intercepts we have. So let's just compare. If the discriminant is positive, so that would mean that this is a positive number. What is that going to mean? Well, that's going to mean that we have two places at which this crosses, right? Because you have the negative b plus that over 2, and you have the negative b minus that over 2. You have the two answers. So you have two solutions. And what are the two solutions? Well, they essentially are whatever this answers. What if the discriminant is 0? So what if this is all 0? Well, it's not going to even play a part. There's no plus and minus anything. So we just have this one answer, and what that looks like is it just touches at one point, one solution. And that one solution to the equation equaling 0, obviously this is a response to ax squared plus bx plus c equals 0, finding x for that. The one solution is going to be negative b over 2a, which is the x vertex point. And finally, what if it's negative? Well, if this discriminant is negative, it's impossible to exist. So it actually makes this all does not exist, which then means that it's floating in the air and has nothing at which it crosses, so 0 solutions. So now that we have some more things to look for, let's take a look at a few functions and say what we can about them. So we can consider where does this function cross 0? Where does it cross the x-axis? What are its solutions? What kinds of solutions are they? And we can also answer the optimization type problems of what is the min or max? How does it open? What's the extreme value? So let's see what we can say. Well, discriminant is b squared minus 4ac. So that's going to be negative 1 squared minus 4 times 1 times 1. That's 1 minus 4, that's negative 3. The discriminant is negative. So if you remember with your formula, what that means is that it doesn't exist. Therefore, there are none. There are no x-intercepts. It's floating in the air. So it would have no solutions equal to 0. Great. That's good to know. What else do we know? Well, what's the vertex? Well, we could complete the square, or we could remember that negative b over 2a, which is part of the quadratic formula, is our x value of the vertex. So we could actually take a shortcut and just find that and then find our y value. So let's do that. That's going to be x value of 1 over 2. And then we can find whatever 1 over 2 is input into our function. So that's 1/4 minus 1/2, which is 2/4, plus 1, which is 4/4. So that's going to be 1 minus 2 is -1 plus 4 is 3/4. So 1/2, 3/4 is our x-intercept. 1/2, 3/4 is our vertex. What do we know about its shape? Well, the leading term is positive, and it's 1. So there's nothing being factored out under the process of putting it into vertex form, completing the square. So the shape is just regular, and it's opening up. So opening up, parabola shape. Therefore, it's got a minimum value. And the minimum is found at that vertex. So we know it starts there, and it's going to open normally. So it's approximately going to look like that. Let's say some more about this one. Now this one has a negative up front. So if we completed the square, we'd have to factor out the negative. Right away, that tells us that the opening is down, but it's also regular. So it's a regular parabola facing down, which tells us that it has a maximum. So just seeing that negative has told us a lot. What about the vertex? Let's do the vertex while we're at it. So x is going to be -b over 2a, which is -4 over -2, which is 2. So the x value is going to be 2. So if we find what happens at 2, we get -4 plus 8 minus 4 is -8 plus 8, which is 0. So 2, 0 is the vertex point. We could have also completed the square, but we have developed this formula from completing the square, so we can use it if we like. So we know that, and for the graph, we know that it's going down, and there's nothing being factored out here, so it's just a regular parabola shape. Touching at one place. So remember, the discriminant, if we find the discriminant, which is b squared minus 4ac, we see that the discriminant is 0, which means that it only touches in one place, and it only touches at -b over 2a, which was already found to be 2. Let's try one more. What do we know about this graph? So this one is positive, so it's facing up. Its shape is altered, it's all halved, so it's flatter, parabola. So we know that it has a minimum at the vertex. And the vertex, the x value is going to be -b over 2 times a, which is -2 over 1, which is -2. The y is going to be found by plugging the -2 in. Giving us half of 4 minus 1, which is 2 minus 4 is -2, minus 1 is -3. So the vertex is -2, -3. So where is the vertex? -2, -3. and it's facing up. So it will cross at 2 places. Now we can check that with the discriminant. B squared minus 4ac if you like, which is 4 minus plus 2, which is 6. So this tells us there are 2 solutions, and they are found by using the quadratic formula. So we could find the x-intercepts by employing the quadratic formula. So the 2 points will be -2 plus root 6, which is 0.45, or -2 minus root 6, which is -4.45. So you can see they'll be approximately like that. But you should find some more points to make this a little bit smoother of a graph.